Alright, kiddos. So for your third and final activity, and I have to apologize for things sounding a little echoey. I had to switch headsets, and hopefully this works out a little bit better. Our third and final activity is going to take place on page 57. So we're going to be working on calculating legs of right triangles. Now, before we get going a little bit further, I want you to kind of think about. So we have our triangle, okay, and there are three parts of a triangle, okay. The two parts that I have very poorly highlighted in yellow are, well, let's try a different color. Oh, let's just, okay, take two. Let's try this again. All right. So what I have highlighted in black on said triangle, okay, right here, these are what we call the legs of the triangles, okay. And then the third part that I have highlighted in green, this is what is called the hypotenuse of the triangle, okay. Now, our legs tend to be a squared and b squared, okay, or a and b, I should say, and then not a squared and b squared, they are a and b, okay, and then our hypotenuse we usually use is c. And then the angle that is opposite of the hypotenuse tends to tell us what the type of triangle it's going to be, but we'll get into that later. So the reason why I wanted to point this out to you is because something you're going to need for our next activity, okay? So on page 57, we have given information provided that these are right triangles, okay? So even though we don't see our nice little box to tell us, I am telling you right now, it says it here specifically in the direction provided for right triangle shown here, okay? So what we're going to do then is we are going to solve a squared plus b squared equals c squared, okay? And we're going to determine what the missing number is, okay? So I'm going to kind of erase this several times. So before I get going, I'm going to do just problem one, and then I'll solve it, and then we'll discuss problem two, okay? So go ahead and pause here and solve problem one. So I'm going to go ahead and start. We have a squared plus b squared plus c squared equals c squared, sorry, is our Pythagorean theorem. And as we have discussed, this is what is used in order to find missing side lengths of a right triangle. So I have here, we're looking for a squared, so I'm just going to kind of leave this here. I have b squared, which is going to be 2 squared equals c squared, which is going to be 7 squared. Now some of you are asking, how do I know which one's which? Well, remember, the legs are the two shortest sides of a triangle, and in order for it to go through, it's going to work. Now, we're kind of making an assumption here that a is shorter than 7. Okay, we're just kind of taking a look at it here. So when we go through and we further solve, we have a squared plus 4 equals 49, okay? And then I have a squared, and we have to subtract 4 from both sides equals 45. Now, if you guys remember from working with our triangles, what number that when I square it, I get 45, well, that would be the square root of 45. So A is going to be the square root of 45, okay? And then our next problem, as I erase everything here, and there we go. Our next problem is going to be for this second triangle, okay? I have, once again, a squared plus b squared equals c squared. Now, in this particular one here, once again, our hypotenuse is going to be 4. It's going to be our longer side. So I have a squared plus, or I'm sorry, I didn't mean to do that. A squared, I should say, is actually going to be x, because we know this side length, so it's going to be x squared plus x squared equals 4 squared. Now my x squares I can combine, so I get 2x squared equals 16. And then divide both sides by 2. X squared equals 8. And then what number, when I square, it gives me 8? Well, it's going to be the square root of 8. Okay. So for my two answers, I have x is the square root of 8 for this one. And for my other one, I have a equals the square root of 45. Okay. So go ahead and take a moment now and read problem 2. And then go ahead and pause the video and solve problem 2. Now, problem 2 states the triangle shown here is not a right triangle, even though it looks very, very close to one. What are two different ways that you can choose and tell if the values, what are two different ways you change one of the values so that it can equal a right triangle? So, first off, some of you may be looking at this and going, well, that looks like a right triangle. Well, it's not. So, we have 4 squared plus 6 squared equals 7 squared. So I have 16 plus 36 equals 49. And then we're going to have 16 plus 36 is going to give me 52. And 52 equals 49. Is this a true statement? No, this is not a true statement. So, so then the question then says, okay, well, what are two different ways you can change one of the numbers so that it can become a right triangle? So let's just take a minute here and look, okay? Let's just say, for example, it has to equal 49, okay? So we can change a whole bunch of numbers to try and figure out how to make this work. So let's go ahead and change this 16 here, okay? We're going to cross this 4 off. We're going to leave this 6 squared, okay? And we know some number plus 36 equals 49, okay? Take a moment and think about what that number is. What plus 36 equals 49? Okay, well, that mystery number is going to be 13, okay? So we know that 13 plus 36 equals 49. That is a true statement, okay? So if the side length squared equals 13, then the side itself would have to be the square root of 13, because then when I square the square root of 13, it leaves me with just 13. And then the same can actually be said the other way around. 4 squared plus some mystery number squared equals 7 squared. Okay, well, 16 plus what equals 49? Well, we can kind of do the exact same thing, and then we can do, okay, well, 16 plus 33 equals 49, and then what number squared equals 33? Well, that would be the square root of 33. So that's our other way that we can prove and create this into a right triangle, okay? So these are the 3 videos that I have for you guys. There's multiple things I want you to do. I've already got the answers posted online. I want you to do your summary on page 58. I want you to do your reflection on, I believe it is page 98. I'm going to double check here real quick with the book I have in front of me. 98 is, yep, page 98, lesson 8. And then after